Okay, welcome back. Here we go. Lesson 18, add and subtract fractions. From what I can see, adding and subtracting fractions is where some people tend to go astray in terms of having their rules in order of what they're allowed to do and not allowed to do when they're operating on fractions. So I really hope to clarify this and help you out. So let's get started with some vocabulary. Fractions that have the same or common denominator are called like fractions, and fractions that have different denominators we will call unlike fractions. So, for example, 2/5 and 4/5, we call those like fractions, same denominator, right? And 5/7 and -3/7, like fractions. Separate the world here. Unlike fractions, 2/3 and 3/4, because of different denominators. 5/6 and 5/12, different denominators. So, something that we know is to add or subtract like fractions. I have a little sort of bubble here for you to bear in mind, is not bad. So if you have a over b plus c over b, that's a plus c all over b. You keep the same denominator. For example, and I have a little example for us to do together over here, 18/26 minus 4/26 is just 18 minus 4 all over 26, which is clearly 14 over 26. But I have a little hint here. Don't forget to write your answer in simplest form. If it is not in simplest form, you just divide out all common factors larger than 1. So just kind of look at the numbers 14 and 26 and say, gee, what do they have in common? Well, 2. 2 goes into both of those numbers, right? Because they're both even. So you say, okay, I'm going to divide the top by 2 and the bottom by 2. So you're dividing by the common factor of 2. So then you would arrive at 7 over 13, and that would be simplest form. Okay? So this, long story short, this ends up being 7 over 13 when you reduce it. Okay? So I'll just kind of hover the answer over here. All right, so again, when you're adding fractions, or subtracting fractions for that matter, that have the same denominator, you just keep that denominator and sort of travel straight across on the numerators, like 18 minus 4 would have been 14 over 26. So I hope you're looking at that and thinking, okay, that wasn't too bad. Let's try again. Here's a longer one. All have the same denominator. So note to self, same denominators. Life is good. I always say life is good when you have the same denominators. It's not as much work, right? So that means we can sort of zoop, travel straight across on the numerators. And you can even write, if you like, 3 minus 5 plus 2 minus 6 all over that denominator of 8. And then you just kind of crunch that out in your mind, and I'll talk that through. 3 minus 5 is -2. Plus 2 brings me to 0, minus 6. Okay, well, that's going to bring me to -6 all over 8. But again, when I arrive here, I have to ask myself, can I reduce? Yes, I can. There's a common factor. So -6/8, if I divide the top by 2, I divide the bottom by 2, common factor of 2, then I'm going to arrive at -3/4. And by the way, if you float your negative out front, so if you say -3/4, or if you say -3 all over 4, they're the same thing. So you can float your negative out front of the entire fraction, or you can put it in the numerator. That's just a style thing. Okay? Hope that helps. So when the denominator's the same, life is good. We just travel straight across on the numerators and gather what we're left with after those operations and reduce if need be. All right. Let's look at the next slide. And that was my reminder. I just gave you that reminder on negative fractions. If you float your negative in the numerator, you float your negative in the denominator, or you just float your negative out front of the entire fraction, those are all synonymous. So negative signs can reside in any of those three places. Okay? That was just a brief reminder on that. To add or subtract fractions, though, that have unlike or different denominators, we write the fractions as equivalent fractions with a common denominator. And you try to find the common denominator, so you have to be able to identify the least common multiple of the denominators to do that. So let's take a look. If you look at 12 and 18 and the LCD, the least common, or the LCM, the least common multiple, doesn't instantaneously pop in your head, you can do the prime factorization for 12, the prime factorization for 18, and then notice you gather the most amount of, let's see, the greatest number of 2's, the greatest number of 3's that appear in those prime factorizations. So this has 2 2's, this only has 1 2. I took the most amount of 2's that either guy has in their prime factorization. This guy has 1 3, this guy has 2 3's. I took the most amount of 3's that either has in their prime factorization. And I just multiply that out, and I got the LCD. I know that when you read that kind of thing in a book, it doesn't make sense. So let's try this in real time together. Here we go. Do a prime tree for 16 because we're trying to find the least common multiple here for 16 and 20. So prime tree for 16, prime tree for 20. 16 breaks into 4 and 4, and that's clearly going to break down into a product of 2's, right? 2 times 2 times 2 times 2. 20 really means 5 times 4. 5's prime, I'll circle it. 4 breaks into 2 times 2. All right, now let's try to apply this whole business about the most, right? The most amount, and kind of draw a dashed line here. The most amount of 2's that anybody has. This guy has 4 2's. This guy has 2 2's. The 4's win it. So I need 4 2's. So I'm trying to gather the least common multiple. I need the most amount of 2's that either of them have. And so this 16 doesn't have any 5's in its prime factorization, but 20 has a 5, so we're going to need that 5. And that's it. And you crank that out. So 2 times 2 times 2 times 2 makes 16 times 5 makes 80. And voila. Voila. 80 is the LCD, which is the LCM, the least common multiple, least common denominator. So that means that if I was going to go, here's the big picture, if I was going to go and try and add 5/16 plus 3/20, I'd have to morph both of those fractions into equivalent fractions having that LCD of 80, which we're going to be doing in a moment. So it's like, how do you do that? So once you find the LCD, here's the recipe for adding and subtracting unlike fractions. You write each fraction as an equivalent fraction having that LCD, and then you add or subtract your like fractions and write your answer in simplest form. Okay, so here clearly I have the answer snipped in, but let's see. Okay, so if I did a prime tree for 9, if I did a prime tree for 12, and 4 breaks into 2 and 2, I could identify the LCM as having the most amount of 2's and then the most amount of 3's. Well, this guy has 2 3's, this guy only has 1 3. I'm going to take the most amount of 3's, so I need 2 of them. So the most 2's and the most 3's that either one of those fractions has. Well, 2 times 2 is 4, and then times 9 is clearly 36. So now I know the LCD is 36, but here comes the fun part. 1 over 9 is equivalent to something out of 36, and 7 out of 12, because we're trying to add these two fractions, 7 out of 12 is equivalent to something out of 36. And you say, well, how do you do that? How do you morph them into both something out of 36? Well, you do it legally, meaning how does 12 become 36? Times by 3. So we can multiply by 3, but whatever we do to the bottom, we got to do to the top. I call it the do-do rule. You can't just multiply the denominator by 3 without simultaneously multiplying the numerator by 3 to keep it legal. It's like multiplying by a scaling factor of 1 then, which doesn't affect it. So 12 times 3 is 36. 7 times 3 is 21. Aha! So 7 out of 12 is equivalent to 21 out of 36. So that's what we mean by writing equivalent fractions. So we did that in a legal way by multiplying the denominator and the numerator by some value. Try again. How does 9 become 36? Times by 4, right? So times the bottom by 4, times the top by 4. 1 times 4 makes 4. Aha! So 4 out of 36. So once you have, like fractions, life is good. So now you've got 4 out of 36 plus 21 out of 36, which makes 25 out of 36. And that was the final answer. So remember, I had snipped in the final answer up here. We could even scoot that down. See? So I would not have known that was the final answer unless I would have found that common denominator of 36, and force myself to, big note to self, write equivalent fractions. You got to kind of play that game over and over again until you get comfortable. All right. Another really important piece or component of the LCD is that it helps you compare fractions to know which one's larger. So, when I look at 3/5 and 4/7, I don't instantaneously know which one's larger unless I convert them to decimals, which we haven't even talked about yet. That's later on in the year. So converting these to decimals is an option, but not yet. So one important application of the least common denominator is to help us compare fractions. So think of, now's a time where people think about elections a lot, right? So if you say 3 out of 5 people like that candidate, is that more or less than 4 out of 7 people liking a certain candidate? Well, let's get the LCD. Clearly the LCD with 5 and 7, they're both prime, so you can multiply them. So clearly the LCD is 35. So the question is, 3 out of 5 is equivalent to something out of 35, right? And 4 out of 7 is equivalent to something out of 35. So if you both write them in terms of, if you write them both in terms of the LCD, having the LCD, you'll be able to compare them. Who's greater than who, right? So how does 5 become 35? Multiply by 7. So you multiply the top by 7. I'm just going to even write that here to get 21. Okay, so we'd have 21 out of 35 for that fraction. Here, how does 7 become 35? Times by 5. So I have to multiply the top by 5 as well to get, well, 4 times 5 would be 20 then. So I've got versus 20 out of 35, and look at that, they're very close, but one's bigger than the other. Clearly 21 out of 35 is more than 20 out of 35. And so that tells us then that 3/5 is more than 4/7. And what's neat is in our near future we're going to be getting decimal equivalents to these. And you say, oh yeah, this decimal is larger than this decimal. But we haven't talked about decimals yet, so let's just hold off on that. Okay? So the final symbol there, when you say insert a less than or greater than symbol to make the sentence true, the final answer to that was that 3/5 ended up being greater than. And until you get comfortable with those symbols, you can even write the words is greater than 4/7. Okay, hope that helps. And I believe this is our final. Actually, I don't want this podcast to be too long, so I'm going to cut this one right here at this notion of comparing fractions, and I will do this next evaluating expressions. I'll do that on another video. So we'll have part 1 and part 2 of the notes. Okay, good luck out there.